All right, another day of computer science. Today was about tuples, sets, dictionaries. So these are data collection kind of types. So those are the four data collection, data storage maybe types we can call them. I don't think you can necessarily call them a type, but it's lists, sets, dictionaries, and tuples. And so tuples are basically like lists, except you use parentheses instead of brackets, and they are immutable, right? You can use a tuple function called tuple function, and within the argument you use, I think it's any iterable, which is it's broader than just sequence types, but at this point we've only learned about sequence types. We haven't learned about iterables. So basically you can use any sequence type as an argument for the tuple function, and it will create a tuple. Okay, sets are, you create them using curly braces. They are unordered sets of unique elements. You cannot, they're not ordered. So if you try to modify, change, or add anything to a tuple, that will create a type error, I believe. If you try to modify an element with an index expression for a set, that will produce a type error, I believe. Dictionaries, key value pairs, I don't think I really took any notes on them though. Curly braces as well. I was reminded of the type function. So the type function will tell you what type an object is, I believe. I don't know if it's only objects, but what type of a piece of data is. And class, I kind of got introduced to the term of class. We didn't really cover it yet really, but class is it's related to type, but it's not exactly the same. I think it has to do with defining a new data type, so maybe kind of like along the lines of named tuple. So let me check out what I'm missing. Okay, for collection type good, tuples type error good. You can use max, min, sum, len for tuples, just like lists. You can use all the list functions on tuples, or that are compatible with lists for tuples, except for the methods like add, pop, remove. Those will create type errors. Right, the order of a set is randomly created, so there really is no order to it. Sorted. The sorted function takes a set and orders it. And actually outputs a list, I believe, but it's, I don't know if it's a list, but it's ordered. So sorted function, that was a new function we learned about. You can use del on to delete items within a list. Okay, that's it for right now. Also, I did some leet code yesterday for the first time. I actually completed a leet code problem, so that was pretty cool to do. I mean, we're only in week 7 here, able to actually start doing more complicated problems. So that's it for right now. Talk to you later today. Welcome back to computer science. Okay, so what did we learn about yesterday? We were working through dictionaries, I believe. Dictionaries are data types known as dict, D-I-C-T. That's the type of data they are. They are collections, or they're containers that contain key value pairs, associative relationships. They store associative relationships between keys and values, aka key value pairs. A key is essentially the name, or the name-ish. It's something stored in a dictionary. It can be any sequence type, I believe. And then a value is anything associated with that key in the dictionary, any data associated with a key. And dictionaries are created using curly braces. Occasionally, you'll basically write every key value pair on its own line within the dictionary. We might have wrapped up on sets yesterday too. Anything else with dictionaries though? They are mutable, I believe. Yeah. How do you add a new thing to a dictionary? You say dictionary name, and then within brackets you say the key, and then gets, so assign it a new value, or assignment a value. That's how you add a new one. How do you delete? You delete using del, I believe. So del space dictionary name, and then within brackets the key value, the key you want to delete. How do you modify a current key value? You can overwrite the key value by essentially assigning a new value to a key using just like as you would do if you're creating a new key and value. So yeah, you can access using dictionary name, and then within brackets the key. That's how you access certain values. If you try to delete a key that doesn't exist, you'll get a key error. I think that's probably just about everything. Maybe I'm missing some stuff. Okay, good. Represents the dictionary. Yeah, good. Associated maps. Keys with values. Good. Created using curly brackets surrounding key value pairs. A key is a term that can be located in a dictionary. Can be any immutable type. That's what a key can be. Okay, interesting. Value can be any type. So I got that wrong. I thought it was sequence type. It can be any immutable type. Value describes some data associated with a key, such as a definition. Okay. Order is maintained in a dictionary. Okay, accessing entries, good. Mutable. Deleting, overriding, writing new, can replace. Oh, you can create an empty dictionary using just curly brackets. And I remember we started yesterday with set theory operations, the last two, which were difference. So set one dot difference, and then as the argument can be set 2, 3, 4, as many as you want, or just one. This will give you the elements that are within set one, but none of the other sets that you mentioned. Symmetric difference compares two sets only, and it will output a new set or return a new set in which only it will return a new set with elements that are in only one of the sets. Right, so they're not in both sets. They're only in one or the other. Okay, there we go. So it's Wednesday. I've got an assignment due tomorrow, which is Gonna be a bunch of MSPs, so I'm about to just do a bunch of mini programming projects. So I'll be back to recall what I did in a little bit. All right, I just ripped through, started and finished 3 programs. One of them takes a input driving speed and input speeding limit, and then outputs a speeding ticket cost based on differing speed differences. One of them basically took a simple password and made it more complex by changing lowercase i's to ones, lowercase a's to ats, lowercase m's to capital M's, lowercase s to capital S, capital B to 8, and then adding an exclamation point to the end. And so we did that using a while loop, an iterator, variable I, and sequencing, or cascading if a statement. And the other program, what was this? Something really simple. It basically the program took in 2 different strings and then outputted whether which one was longer or if they were equal. So that's all for right now. May or may not have time to do another session later today, so that may be it for today. Talk to you tomorrow. See ya.